Sathyabama Institute of Science and Technology.
Hello everybody, I am Nafees Muneera, Assistant Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. In today's class, we are going to see about Minimax Algorithm in AI. This is one of a search algorithm which is mostly used in game theory and decision making. The insights of this particular algorithm is it uses recursive and backtracking for mostly game theory and decision making. It is mostly used in games like chess, checkers, tic-tac-toe and various other two-player games only. It is sure that all the move made by the player will be an optimal move. Both the person who is playing as well as the opponent, both the moves will be optimal. Here it uses recursive traversal so that it invades all the nodes in the tree. Here we get into the working principle of the Minimax algorithm. So this is a game tree generated by the system. Before we start solving, we need to assign certain things to the layers of the particular game tree. So this is a 4-layer game tree where the first is the max and the second layer is the min, third is the max and the last is the terminal node. So there is no assignation there. So this terminal leaf node will carry the values here. Now before we start assessing, we need to assign a worst case value to the max as well as the min. Here the worst case value, that is the initial value the max will take is minus infinity and min will take is plus infinity. Now considering this, we will try to solve this particular game tree. Okay. Now we start the traversal. Now in the traversal, right from the root node, we start traversing to the leaf node. Since this particular algorithm uses the depth first search, it is traversing from the first to the leaf node, last leaf node. In the last leaf node, the value is 4 and it compares with the branch node wherever it is, that is the max level. Here we have to assign the value. Initially it will not have value, here we have to assign the value. So what will it take? The initial value of the max will be minus infinity. So it will compare which value to take, whether 4 or minus infinity. Since it is this layer is been assigned with max value, the comparison takes place and the particular node will be assigned 4. Again that will be traversed to the right side node and there the comparison again will take place. Which one is maximum, whether 4 or 3? So definitely 4 is maximum. So the 4 will be assigned to the D node. Then it traverses to the next node, that is the E node. Here also there is comparison of two values, 6 and 2. So out of this obviously 6 is the maximum value and then the F node, and here also the comparison between the 2 and 1, 2 is the maximum value. In the initial step is it will get compared with the minus infinity value, that is first it will compare with infinity. Obviously the number is a positive value, so that will go first. So we ignore that and we directly compare the two and we take the largest of that. And here also next it comes to the G node and here the comparison is among the 9 and 5 and the G node takes the maximum value, that is the 9. So it has completed one level of traversal. Now it moves to the next layer. Next level, here you can see that it is been assigned with the min value. So the worst case value where the min take is the plus infinity value. Now here we have to compare the values of both the nodes here with the plus infinity value and we have to take whichever is greatest. Now here 4 and plus infinity. So whichever is greatest, we will be taking 4. Then 4 will get compared with 6 and we will take minus infinity. Then again it will take whichever is lesser and it will be assigned to B, and among these whichever is lesser, that will be assigned to C. Now you can see that the B has taken the lesser value 4 and C has taken the lesser value 2. Among these, this is the minimum value and among these two, this is the minimum value. Now it has completed one level of traversal. Now it goes to the uppermost level where the value is maximum. So here the comparison takes place between 4 and 2 and the worst case value of the max will be minus infinity. Now 4 and minus infinity, obviously 4 is maximum. So 4 will go there, and here 2 and 4, whichever is maximum, 4 is only maximum. So we will retain 4 to the A node. So now you can see that the traversal has been did to all the nodes in the particular game tree. Now we have solved it and we have reached the root node. Now the value of the root node is 4. Now the player Max will take the value of 4 when he plays this particular chance. Since this is a 4-layer node, we have completed the traversal immediately. When it is a very big layers, when it has lot of chances, then the time for solving this particular game will be very long. Okay. Now the properties of this particular algorithm, that is, it is a complete algorithm, that is, it gives a complete solution. If there is a solution for this particular search, then that definitely it will produce a solution. So we say that this algorithm is complete. Then optimal, it performs the perfect optimal thing for both the players, that is, both the moves of the players in each and every step will be optimal. And coming to the time complexity of this particular search algorithm is the same as of depth first search, because it follows that strategy. So the max algorithm's time complexity is order of b to the power m, where b is the branching factor of the game tree and m is the maximum depth of the tree. And space complexity is also the same as that of the depth first search algorithm, which is order of b into m, where m is the maximum depth of the tree and b is the branching factor of the tree. Now we are into the limitations of this particular algorithm. Now we have solved that particular game tree. Now we are into the drawbacks, that is, this particular algorithm, it is even though it is complete, it takes a very large time to solve when the problem is complex. That is, there are certain games like chess, go and all, it is time consuming. Since there are huge branching factors, there are many options to the players to move, right? So it has lot of choices for them. So it's because of that it is time consuming. So in order to avoid that, we have come out with a better version of this particular algorithm. The drawback of this particular thing is being overcome by the alpha beta pruning algorithm, where the unwanted moves by the game is being avoided. That is, the unwanted traversal of the game tree is being avoided and a better optimal solution is being arrived at a quicker time. So we will see the remaining in the next subsequent classes. Thank you.